Okay, for today we're going to look at vectors and scalars, and the first thing I can tell you is to make sure your calculator is in degrees. So for all this unit, most of our units, you're always going to want to make sure your calculator's in degrees. We don't work things in radians, so go ahead and do that. I know for those of you that are in pre-cal, throughout the year, there's going to be times when you're switching back and forth, so always double check, make sure your calculator is in degrees before you get started. Okay, so when you're looking at a vector versus a scalar, okay, a scalar is simply just anything that has magnitude, but not a direction. You're going to hear the term magnitude a lot. Magnitude just means a number, okay, so it's some value, 5, 20, 30, 40 feet, 6 blocks, 10 miles, okay, but you don't really know exactly where someone's talking about. So if you said that you lived 3 miles from here, okay, well, where? Okay, I don't know if you're north, south, east, west, where you are. So that's what a scalar quantity is. So here's some examples of your scalar quantities: speed, distance. Remember we talked about speed and distance. Those always have to be positive values. Okay, which is why they're not telling you anything about a direction, they're just a magnitude. When you look at your Fitbit at the end of the day and it tells you how many steps you've taken, it doesn't tell you which way you traveled, it's just a number, it's a magnitude. Your car's odometer, same thing. It's just telling you which way you're going, or just tells you how many miles you've driven. It doesn't tell you if you're going north, south, east, or west. It doesn't subtract if you start going backwards. So that would be another example of a scalar quantity. When you drive your car, it says 65. It doesn't tell you which way that is, though. Okay, age, heat are also other examples of scalar quantities. So a vector then is going to be any quantity that has both magnitude and direction. So whenever you're talking about a vector, you have to say you're going 65 miles per hour east. Okay, so velocity is a vector. Remember we said that it can be positive or negative. That positive or negative is telling you the direction of it. Acceleration, same thing. Force, which we'll get to in the next unit. When you're looking at vectors, by standard convention, you normally put an arrow over it to indicate that it is a vector. So velocity would have an arrow, displacement would have an arrow, acceleration, force, those would all have arrows over them to indicate that they are a vector. Okay, when you're looking at them. When you're looking at vectors, what you want to do is you can always draw vectors as arrows. Okay, the arrow has to have the size that you draw the arrow is the magnitude. So if you have a vector of 2 and a vector of 4, the 4 vector should be double the size of the other arrow. Okay, what scaling you use is up to you. If something's a little bit bigger, if you're looking at 5 and 7, just make sure 7 is obviously bigger, but don't make it double, because 7 is not double 5. So just scale it to some degree that makes sense. Okay, so when you're looking at vectors, okay, if they're in the same direction, so they're both east, north, south, whatever direction, you just simply add them. So here you have a man walks 54.5 meters east, then another 30 east, calculate his displacement. Okay, so you would draw one vector going to the east, okay, and then what you're going to do is you're going to add the other vector at the tail of the first one. Hang on just a second, I gotta grab my son. Okay, so you add the vectors, what we call tip to tail. So if you look, the tail of the second vector is going to line up on the tip of the first vector that you have. Then you're going to draw a straight line from the tail of the first vector to the tip of the second vector. So you start over here on the tail of the first one and you go to the tip of the second one, and you add them tip to tail. That's how you always add vectors. Your resultant vector is your answer. It's the final vector that you draw, and we call that the resultant. So in this case, you would just add them, 84.5. Okay. If you notice again the scaling, you can tell that this 54 is obviously bigger than the 30, just for scaling purposes as you go through it. Okay, again, you'll notice that the magnitude is looking at the arrow size, and then the arrowhead is going to point in the direction that it was traveling. Okay, if they're going in opposite directions, then you're going to subtract. Okay, so if east and west, you would subtract. West is going to be your negative. East is always going to be positive. We always go by standard convention when we're looking at things. So we're going to add the vectors again. You need to be able to draw these vectors. I know that these are like really simple numbers, but you need to also be able to draw the vectors. Okay, as they appear, you're going to use vectors a lot throughout the year. So you're going 54.5 meters to the east, and then you go 30 meters to the west. So if you notice, again, we're adding the second vector always at the tip of the first one. That's where the tail of the second vector meets, that tip to tail method. And then your resultant vector is going to go from the tail of the first vector to the tip of the second vector. So it just follows that line, and then you draw a straight line. Where did you start? Where did you end up? And that's your resultant. Okay, if your vectors are perpendicular, for example, you're going to use the Pythagorean theorem. So here you have a man walks 95 kilometers east, then 55 kilometers north. Calculate his resultant displacement. Your resultant just means that answer, that final vector. Okay, again, draw it out. Yes, I know you can just use Pythagorean theorem, okay, but still draw it. So there's your first vector. There's your second vector. Okay, you start there. You end at the tip of the second vector. Again, you have that tip to tail method where you add them. And then your resultant goes from the tail of the first vector to the tip of the second vector. Make sure you draw that line along like thinking about like a path to get there. So that way you make sure you get the right angle. Okay, again, your hypotenuse is just your resultant. Okay, and then your legs of your triangle are your components. You've seen this before. Your horizontal and your vertical. This is just a review. Okay, and then you'll do the Pythagorean theorem. A squared plus b squared is c squared, so 95 squared plus 55 squared, add it and square root it. You're going to get 109.8 kilometers. Okay, for the perpendicular vectors. Okay, however, we want to look at your directions. Okay, remember we're always looking at this head, toe, tip to tail method. Okay, you've all seen the coordinate plane. However, when we're looking at our angles, it's important to note that we never say things, so if you're anywhere in between or you're not on east, north, west, and south, we never say things are going northeast, okay? Because what is northeast? Which way are you actually facing? What we call things is how you actually name them. We do things like north of east, west of south, okay? So in order to name your vector, whichever coordinate axis you're touching, that's going to go second. So in this case, you're touching the east axis, so that's going to be the second letter, and then which side of that are you on? Are you on the north side or the south side of east? So if I look at my angle, I am north of the east axis, so north of east. Okay, if my angle was up here instead, then I would be touching the north axis, and I would be looking to see which side of that I'm on. I am on the east side of north. Do the same thing over here. My angle in this part would be touching the west axis. I am below that, so I'm south of west. On the other side, I'm touching south. Which way on south am I? I am west, so it would be west of south. Okay, then we have north of west. Again, same thing, I'm touching the west axis. Which side am I on? I'm on the north side if I'm up here. Okay, then we have west of north, south of east, and east of south. Okay, so again, when you're naming these, you look at which angle which axes is your angle touching. That letter goes second, and then you just see which side of it are you on. Are you on the north or south side? Are you on the east or west side? Okay, as you go through it. However, so when you look at this angle, it says north of east. However, that doesn't tell me which way I'm traveling. I just know I'm going north of east. So I would face east and then go a little bit north, but how much a little bit north? Okay, so to do that, we're going to have to use one of our trig functions, sine, cosine, or tangent. I personally don't care which one you use. I prefer to use tangent since that's the two that were given to us, since they gave you the opposite and adjacent side. If you want to use sine or cosine, your answer might be a little different, just because if you're rounding your hypotenuse, then that would cause for your angle to be rounded. So I just always prefer to use whichever functions they give me. So if they gave me the opposite side and the hypotenuse, I would use cosine, or I would use sine. Sorry, mom brain is kicking in really bad right now. So it's up to you. So I would use tangent. Again, make sure your calculator's in degrees. Do the inverse tangent to find your angle, and you come up with 30 degrees. So your final answer would be 109.8 kilometers, 30 degrees north of east. Okay, that tells me exactly where to go. So if I go to 30 degrees north of east, so face north or face east, go 30 degrees north of where that I was just facing, and then walk 109.8 kilometers, I would end up at that spot. Okay, so if you're missing a component, so let's say now you're going 65 meters, 25 degrees east of north. I want to know what were the horizontal and vertical components. Okay, again, with vectors, you always want to make things into a right triangle, because in that way you can use the Pythagorean theorem. It makes the math a little easier if it wasn't. So to do that, okay, again, draw your vector. So you would draw your resultant 65 meters at a 25 degree angle. That's a really bad 25 degree angle, but it says east of north. So that means this is my angle up here, because I'm on the east side of north. Okay, so I'm looking for my horizontal and vertical components. VC for vertical component, HC for horizontal component. So I'm just going to use sine and cosine to do that. So my, be careful when you're doing sine and cosine. Okay, remember, sine is always your opposite, cosine is always your adjacent. So in this case, my adjacent side is going to be my hypotenuse times cosine of theta. So my adjacent side is actually my vertical component. Okay, you have been trained that cosine means x and sine means y. Okay, that's not always true. By definition, cosine is the adjacent side over the hypotenuse, period. Yes, normally when you're doing things, cosine ends up being x. Okay, however, it's all based on where you draw your angle. Okay, so when I look at my picture over here, it says I'm east of north, so that means this is my angle right here where I put this 25 at. So when I do my adjacent side of my triangle, that's now the vertical component. When I do the opposite side of my angle, that's the horizontal component. So yes, normally cosine is x, but it's not always going to be that way. So be careful how you draw your pictures. That's why I'm telling you on these problems, draw your diagram, because if you label 25 degrees and you go from 0 and you go to the east axis and then go north of that, that would tell me right away that your components are just going to be switched. Okay, so make sure you get that right. If you have multiple vectors on angles, what you want to do, so if you have them, you're going to get them, sometimes there's going to be multiple different vectors on these different angles, so I could add on a couple more to it. What you want to do is find all your x components, exactly the way we just did, using either sine or cosine, depending upon which one corresponds to your horizontal components. And then do the same thing for the y's. And then you're going to add all of your x's up, add all of your y's up, and then use the Pythagorean theorem to find your final x and y value, to find out the actual x and y value of your resultant. So find x's for each piece. Find all your x components, your horizontal components for each one. Pay attention to positives and negatives. If it's west, it's going to be negative, okay, as far as when you're looking at your horizontal pieces. So keep that in mind. When it says here to add all your x's and y's, keep in mind positives and negatives, because that will make a difference in your answer. All right, so let's try one. So you have a bear is searching for food, okay, and it wanders 35 meters east, then it goes 25 meters north, and then it gets frustrated. It wanders another 12 meters west and then 6 meters south. Calculate the bear's displacement. So what I want you to do is draw a picture. Okay, draw a picture first. So you go 35 meters east, then 20 meters north, then you go 12 meters west, and then 6 meters south. So what you want to do is add all of your x's first. So add your x components first. So I have 35 meters east, 12 meters west, I'm going to subtract. So that's going to give me 23 meters to the east. Then I'm going to do the same thing with my y's. 20 meters north, 6 meters south. Again, notice I'm still using that tip to tail method. Drawing my resultant, going from the tail of the first vector to the tip of the second vector. So I went 14 meters north. Okay, so I'm going to redraw what I have now. So I know my total x component is 23 meters east. My total y component is 14 meters north. Pythagorean theorem to find my resultant. Show you that one more time. Notice where it fits in. Okay, so your resultant would be going from this, the tail of the 35, to the tip of the 6. Okay, and again, we always want to make right triangles because it makes our lives easier. Okay, do the Pythagorean theorem and inverse tangent to find your angle. So 14 squared plus 23 squared, square root of that is 26.93. Then I'm going to do inverse tan of 14 over 23. Again, when you're using this, that's why I want to make sure you're drawing your pictures to make sure you get the correct opposite and adjacent sides to make sure you get your right angles. Okay, so your final answer should be 26.93 meters at 31.3 degrees north of east. Okay, as you're looking at it. All right, so the next thing we want to do is with velocity. So we've been doing it with meters. Now I want to do the same thing with velocity. Okay, when you're doing it with the velocity, it works the exact same way. So here you have a boat moves with a velocity of 15 meters per second north in a river which flows with a velocity of 8 meters per second towards the west. Calculate the boat's resultant velocity with respect to due north. So they're telling you your reference. So again, draw your picture. So there's my north. Okay, and then the boat goes west. So my boat's really going to travel on an angle. Same thing, do the Pythagorean theorem, and then inverse tangent to find my angle, which would be 28.1. So my final answer would be 17 meters per second at 28.1 degrees west of north, or I can call it by its true angle, and say that it's 17 meters per second at 118.1 degrees. So in order to get that 118.1, all I did was, if you look where you are, you're in the second quadrant, so you would add 90 degrees to your answer. So it'd be 90 plus 28.1 to get that second answer. You need to be able to do it in both ways. You don't know which way it's going to show up on a test or a quiz. Okay, sometimes I may have the true angle, sometimes I may have it in this west of north format. Okay, things like that. So make sure you can name angles in both ways. All right. So now we have a plane moves with a velocity of 63.5 meters per second at 32 degrees south of east. Calculate the plane's horizontal and vertical velocity components. Again, draw a picture. Okay, again, south of east, that's why this is important when you look at it. So that's telling you, since it says south of east, your angle is touching the east axis and you're below it since it says south, and then the value of it is 63.5. So I'm going to find my horizontal and my vertical components. Instead of labeling it as HC and VC, you can always label it as X and Y. That is perfectly fine. When we work out some of the harder problems, I'll go back to using X's and Y's. But just for now, want to leave it that way. Okay, if you notice on this one, this is back to normal. Unlike that other example that we did, your horizontal component is back to being the cosine, the adjacent side, and your vertical component is back to being sine, the opposite component. So again, just double check, okay, with your angles where you're going, okay, for it. I used the true angle when I did my horizontal and vertical components. So I did, if you look at this angle, how many degrees are you from 0? Remember, all the way around is 360. So I did 360 minus 32 and got 328. If you wanted to leave it as 32 and do 63.5 cosine 32 and 63.5 sine of 32, both of your answers would come out being positive. So you would need to remind yourself that since it says you're in the fourth quadrant, that means your Y component needs to be negative. Okay, you could add that in there if you did 32. Or if you use your true angle, it will always tell you, because 328 degrees can only appear in the fourth quadrant, can't exist anywhere else. Whereas if you did 32 degrees, you could say 32 degrees in any of the other quadrants. But most commonly, your calculator is going to assume 32 degrees is in the first quadrant, so it's going to give you a positive number. So that's why I recommend using the true angle. How many degrees are you from 0 going always, and that counterclockwise motion. Okay, so as you're determining your angle. So that's my personal preference, just to make your life a little easier, to make sure you don't mess up your X's, your positives and negatives on your components. All right, we're going to skip this. Okay, so here's another example that we have. So a storm system moves 5,000 kilometers due east, then shifts course at 40 degrees north of east for 1,500 kilometers. Calculate the storm's resultant displacement. So again, draw your picture. Okay, you don't have to draw the X and Y axis, and like I did on mine, it's just to help you figure out where 40 degrees would be a little bit better, but you don't have to do that. It's helpful sometimes, especially if there's like a third vector that you're adding on there, but it's totally up to you. You don't have to. Notice every time I'm doing the vectors, it's always tip to tail, tip to tail, tip to tail. So my resultant vector, okay, would go from the tail of the 5,000 all the way up to the tip of the 1,500. So to do this again, I need to figure out my horizontal and vertical components of this 1,500 kilometer vector. So this one lines up again, right? Your cosine is still your horizontal, sine is still your vertical. So I'm going to do 1,500 cosine 40 to figure out my X component, And then I'm going to do 1500 sine 40 to figure out my vertical component. Okay, but when you look at it, I need to figure out how far in total I moved in the x direction. Because when I'm on that 1500 path, I'm still walking in both the x and y direction. So I'm going to add my 5,000 to that 1,149.1. So that tells me that my total distance in the x direction was 6149.1 kilometers. Okay. My total vertical part was 964.2. So my resultant vector goes along there. And this green arrow would match up as if you drew an arrow from the first one. Okay, all the way across. So I'm going to find my resultant and I'm going to find my angle. You always need to find your angle, okay? Unless it just says magnitude. If it says find the resultant is that hypotenuse. It's your displacement vector. Since it's looking at your displacement, displacement is a vector, so you need magnitude and direction. Okay, if it just said calculate the storm's magnitude of displacement, you could stop after doing Pythagorean theorem. You wouldn't have to find the angle. Again, make sure your calculator is always in degrees. So my final answer is 6,224.14 kilometers at 8.91 degrees north of east. Okay. Again, AP Physics, we're not too specific on your rounding. I think everything out to the hundredths place is fine. Just be consistent. Don't go to 3 and 4. Never use more than 4. It's not that accurate. It's okay. It's fine. Except on your online homework. On your online homework, don't round at all. But for me, everything you do in class, hundredths place is perfectly fine. Okay? So I don't want to see 14 decimal places. Okay, ever. So just stick to the hundredths. All right, so now we're going to try this example. So I'll give you a second to draw your picture. So you have a man pushing a mop across the floor, causes it to undergo 2 displacements. The first has a magnitude of 150 centimeters and makes an angle of 120 degrees with a positive x-axis. So they're telling you the true angle, 120 degrees. The resultant displacement has a magnitude of 140 centimeters and is directed at an angle of 35 degrees to the positive x-axis. So instead of telling you the 2 vectors, they're telling you your answer vector, your resultant, and one other piece. Okay, you have to figure out what other vector would add with that first one to give you 140 at 35 degrees. Okay, so there's vector A. Okay, and then there's vector B, my resultant. So if you look at these 2 vectors, I know that when I add in my second vector, it has to kind of connect the 2 together. Okay, but I have to figure out the pieces of it. So what I'm going to do is I have to find vector B. Vector B is on an angle, so that means I'm going to have to find all of my x components, all of my y components, and then Pythagorean theorem them back together. So I'm going to start, okay, I'm saying if you add those 2 vectors, you would get vector R. Okay, so that's just vector addition. I'm just saying if I add vector A and add vector B, I'm going to get vector R, my resultant. So that means to find vector B, I'm going to do vector R minus vector A. Your resultant vector is always the additive of the other 2. I'm not telling you how to add them. I'm just saying that it is additive, okay, of them. When we're saying adding vectors, they could be adding them as Pythagorean theorem. It could be just adding them together. It could be subtracting them, but you're just calling it adding vectors. So I have to do the x components, okay? Whenever you're working problems, you always have to separate x's and y's. So that means vector b's x component would be r's x component minus a's x component. So my rx component would be my resultant magnitude, which would be 140, okay, that's why I labeled it, and then its angle, 35. They're telling me the true angles for all of these, so it's already set up in terms of x's and y's. And then I'm going to subtract a's component, which would be its result, its magnitude 150, and its angle 120. Which gives me a positive 190 centimeters. Then I have to do the same thing for the y component. Now if you look at vector b, how it's drawn in the picture, you can see that vector b is going east and south. So that means your y component is going to have to be negative. So that's like a hint to you when you look at it. As you draw this, this arrow is angled down and to the right. To the right is east, so your x component's positive. It's going down, so that means your y component has to be negative. So those are going to be my x and my y components for that vector. So now I have to do Pythagorean theorem with my x and my y components. So what I did is I took that vector b, and instead of leaving it arbitrarily off the end of a, I put it where it would belong if I was just drawing that one vector. So I started it at the origin. So it's traveling southeast, and then there's my values from before, 14.6, 49.6, sorry, not a good picture. And you get 196. Then I'm going to do sine. So I just picked to do one. It doesn't matter which one you use, okay, for it. And you get 14.6. Sorry, I misspoke earlier. This 14.6 is my angle that I got, okay. Make sure, sorry, that's why the bad thing about doing these on PowerPoint, okay, and taking care of a baby, you forget things occasionally, okay. So when you do your angle, opposite over hypotenuse, again, you could have used any of the trig functions. So if you look at your angle, it's 14.6, so really it's pointed at 345.4 degrees, or 14 degrees south of east, okay, and that would be your final answer, would be 196 centimeters at 345.4 degrees, or 196 centimeters at 14.6 degrees south of east, because your angle is touching the east axis and you're below it heading south.